So chapter 7, we're talking about scatterplots and things about scatterplots. We have two quantitative variables. So each point on a scatterplot, because you guys have seen scatterplots before, are a coordinate that relates those two different variables. So in this scatterplot up here, this is super complicated, but that's the one that our book is using. We have year, and then that's plotted against prediction error in nautical miles. And what this is about is they have the average error in nautical miles of the predicted position of hurricanes in the Atlantic Ocean. So like they predicted where the hurricane was going to be, and then there was where it actually was traveling, and so the error is what they're graphing. Whatever. Anyway. When you have a scatter plot, though, we want to be able to talk about it. All right, so we can make a scatter plot. Great. What are we going to do with it? There's lots of things we're going to do in chapter 8. But in this chapter, we're going to focus on actually talking about what's happening. One thing to note, when you make a scatter plot, your axes are probably not going to meet, and that's okay. Like you're not going to have 0, 0, and that's fine. Okay, so that's something different than, algebra where you'd have to have 0, 0 somewhere in your scale. So here we can split them up. Any questions about what a scatter plot is? All right, they're great for seeing trends over time, for finding relationships between variables. And so when we talked about one quantitative variable, what did we always talk about if we were looking at a display? What were you always supposed to talk about? Shape, center, spread, unusual features. Well, we want to talk about the similar ideas. We want to talk about what's happening in the scatter plot. They just have different names because we don't have the same exact thing going on as we did before. Okay? So we're going to talk about the association between variables. And I say that because we're also going to talk about correlation in this chapter. And in the English language, it's easy to try to put those in and out. They could be interchangeable, except they can't be in statistics. Okay? So in statistics, correlation is an actual number. It's like a value, like it's a mathematical thing. So you can't say the correlation between this variable and this variable is, and then talk about it. The correlation has to be a number value. So when we're talking about a relationship, we're talking about an association. I'm just trying to get the vocabulary straight because it's going to keep being confusing all chapter. All right? So we're going to talk about an association. And so when we talk about an association between variables, we talk about 4 things, just like we did with one variable. The first one we talk about is direction, if possible. Is it positive? Is the scatter plot going down, so it's negative? If we can give a direction, we want to give a direction. All right. Questions about that? So direction is literally just direction. Once we talk about direction, we'd like to talk about form. Now, most of the ones that we're going to talk about in here are going to have a linear form. They're going to make some reasonably straight association where you have, just increasing, no big deal. They could be curved. So you can say it's a curved association. This could make a parabola. If it makes a parabola, it's obviously not positive or negative because it's both, so you can't pick one. All right, so you are just giving form, you're just giving kind of what shape it is. Just different type of shape here, right? So direction and form. We're going to do a lot of linear forms because that's the type of scatter plot you can do the most with. All right, if you have a linear association, then you can use actual linear equation type things from algebra. So we'll use those the most. After direction and form, we talk about strength. We want to know how strong the association is. And what I mean by that is the tighter the points are together, the stronger it is. So this picture up here in the corner, that's a fairly strong association because all the points are kind of tight together. If you look right here at this cloud, that's a rather weak association because it's kind of just random and there's more scattered about. Okay? So we'll talk about strength in terms of it's very strong, it's moderately strong, it's weak. Okay? Once we talk about correlation tomorrow, we'll also have another indicator about how strong it is. Questions about strength? All right, so we have direction, form, and strength. And then the last thing we look for is any unusual features. Maybe there's an outlier in the scatter plot. Maybe that outlier could change something. So for example, I have some scatter plot about something. There's my scatter plot. What would I say about the direction of this? Positive, right? It's going upwards. What would I say about the form? Sort of linear, right? Sort of linear. And the strength, it's not very strong, but we can at least see some association between, right? But this point up here is standing out from everything else, right? So we might want to mention it. This one especially because what if I got rid of that point? Then it's not positive, right? It's not linear, and it's definitely not strong at all, right? So if you have a point that could affect what you're looking at, or if you have a point that's standing away from everything else, maybe you just want to make note of that. Maybe you actually want to remove it from your data set because it's a mistake or it's causing weird things to happen within your scatter plot. Okay, so you're going to talk about every time direction, form, strength, and unusual features, and you're going to talk about all of that in context. We're going to do an example, but we got those 4 things: direction, form, strength, unusual features. There's not any like socks, anything I can tell you. So first period was like making things up. They said fuds, duffs, or you could just know direction, form, strength, and unusual features. Whatever will help you out. Okay. All right. So here is an example that we're going to, this is describe what the plot shows. We're going to describe the association. So this is, let's say, hurricanes develop low pressure at their centers, and this pulls in moist air, pumps up the rotation, and generates high winds. Standard sea level pressure is around 113 millibars, or 29.9 inches of mercury. Hurricane Katrina had a central pressure of 920 millibars and sustained winds of 110 knots. So here's a scatter plot of maximum wind speed in knots versus central pressure in millibars for 163 hurricanes that have hit the United States since 1851. So we're going to just what the plot is showing. We would say the association between pressure and wind speed is. So what's the direction? Negative. What's the form? Linear. What about strength? It's not like it's not on top of itself, like it's not like the strongest it possibly could be, but it's also not just a bunch of random points, right? So we're going to say that's moderately strong. All right. And any unusual points anywhere? Not. I mean, there's some low points down here, but they're not really doing anything. Right? So the association between the two variables is a moderately strong, negative, and linear. We have to mention those things in context. Questions about that? Could you all do that? Start your homework tonight. Okay. Then just, again, vocabulary reasonings. We have 2 variables. So we have an x variable and we have a y variable. In other classes, they're called different things. In statistics, we're going to call them what I'm going to tell you. A lot of classes use independent and dependent, right? My class, for statistics, the x variable is the explanatory variable because it explains what's happening. And then the y variable is the response variable. So explanatory is x, has an x in it. So, if you, I give you the assignment. The first part of your assignment tonight gives you random scenarios without an actual scatter plot and asks you to name the explanatory variable and the response variable and then what you would think would be happening between the variables, like what the association would be. Okay? So we're not going to do all of these. I'll just do a few. On some of these, the explanatory and response might not matter which direction they are, but most of the time there's kind of a more obvious one that's explaining the other one. So we'll do B first. It's about apples. And it says their circumference in inches and their weight in ounces. Do you think that it matters if the circumference explains the weight, or do you think weight explains the circumference? I think it could go both ways. I lean towards circumference is going to explain weight. So I would say circumference, explanatory, weight, response. Then I would talk about what I think that would look like. So as the circumference increases, what's happening to the weight? It's also increasing, so there's a positive association, right? It's probably linear. And we'll say it's moderately strong, because it's not going to be exact, right? But you would think as the circumference increases, that the weight increases. Any questions about that? Yeah, it could curve at the top because you might like plateau at some point. Any questions about what they were asking there? Let's see here. On C, college freshmen, their shoe size and their grade point average. One definitely doesn't explain the other, so it really wouldn't matter which way you put it. And regardless of what you put, association. No. So it would not. There would be no direction. There would probably be no form, and so the strength would be very weak. There'd be a very weak association between, if at all, between grade point average and shoe size. Yeah, and that one you can't really give an explanatory response because there's not really one that explains the other. You never know, but I doubt it. All right, questions about what I was asking you to do there? All right. The other part of your assignment tonight is to be able to make a scatter plot so you can talk about it. But, like on this one, I understand that there's only 7 values and you could draw that out, and I'll be very proud of you. But most of the time there are more than 7 values. There's like 20 values. So I'm going to show you how to make a scatter plot in your calculator so that this will take a lot less time. I know. So I've got the directions.
Wow, that's crazy.
You'll need these directions again tomorrow, so make sure you don't lose them. All right. Now, we have 2 variables this time. What you need to do ahead of time to decide what you want your x and what you want your y to be. I'm going to go with, we're talking about burgers, and I'm going to say that fat explains calories. That's what I'm going to go with. Okay? So, this is almost identical to making any other plot in your calculator. If you have data, what do you have to do with the data first? You have to put it into your list. So this time, we'll have 2 lists. List 1 for your x variable, list 2 for your y variable, and it is very important that everything lines up. Like 19 goes with 410. 31 goes with 580. So you can't like forget a number and then go back and add it at the end. It doesn't work that way. So in a second when you guys are done typing in, I'll show you how to insert a number if you forget one. Yes, but not everyone knows that. It's number 36 in your book, if that helps. in chapter 7. All right, let's say that you forget a number, because this is what happens. If you're going to make a scatter plot and your lists do not have the same amount of numbers in them, then the calculator will give you an error and it'll say invalid dimension, because you can't make a scatter plot with two lists that don't match up. Right? If you have one list that has 25 numbers and one list that has 20, you have an issue because you don't have 25 like ordered pairs anymore. Okay? So let's say I just accidentally didn't put in the 640. Okay? Well, now I've got a problem. I can see on the screen that I'm missing one. Okay? If you forget one, again, since these have to be in order, you can insert a number. It will always insert it above where your cursor is. Okay, so since I want to put it above the 680, I'm leaving the cursor on 680. All right. You can hit second delete, and that's the insert button, and it puts in a 0 for you so you can replace it. So second delete is the insert button. Okay. All right. Type of function is, and our graph is second y equals. Make sure you only have one plot on. If you have like plot 2 and 3 on, make sure you turn them off. Not, it's going to try to do a box plot on top of a scatter plot on top of a, just make sure you have one on. Scatter plot is the first plot listed. And then I put my X in list 1 and my Y in list 2, but in the event that we are using like multiple lists, make sure that your lists are identified for the right variables. Okay? Then the very last choice, you have the option of using one of the 3 different types of marks for your scatter plot. So you can choose whichever one you would like. Okay? Then you're going to hit graph, and you always hit what after you hit graph? Zoom 9. So it should look something like this. If we were going to talk about fat versus calories, what would we say about the association between fat and calories? It's linear, positive. It's pretty strong. I mean, the points are pretty close together. I mean, they're making, you can see it as linear. If you couldn't see it was linear, we would say it was a lot weaker. Is there any unusual point? Yeah, this one down here. Now, let's say you want to name what that is. If you hit the trace button, then it'll put your cursor on all the individual points, and you can see which one it is. So the one at 19, the burger with 19 grams of fat, seems to be a little bit of an outlier because it's away from everything else. But if I took it out, does it change what I would say about it? No, it's still positive and linear and relatively strong, right? Okay. Yeah, you would just want to say there is a possible outlier at the burger that has 19 grams of fat. Yes. No. It doesn't work that way with 2 variables. So what we've talked about.